Cloud's virtual private cloud provides network functionality to compute engine virtual machines, VM instances, Kubernetes, engine containers, and app engine flexible environment. In other words, without a VPC network, you cannot create a VM instance, containers, and app engine applications. So, each Google Cloud project has a default network to get you started. You can think of the VPC network as similar to physical network, except that it is virtualized within Google Cloud. A VPC network is a global resource that consists of a list of regional virtual subnetworks, the subnets, in data centers, all connected by a global wide area network WAN. So VPC networks are logically isolated from each other in Google Cloud. In this step, I will create an automated VPC network with firewall rules and two virtual machine instances. Then I export connectivity for the virtual machine instances. So that I will explore the default virtual VPC network. I will create the automated network with firewall rules. I'll create a virtual machine instance using compute engine, and we're gonna export connectivity for VM instance. So let's set up the requirements for this lab. I guess the new Google Cloud project and set up resources for a fixed time at no cost. So we're gonna explore the default network. Each Google project has a default network with subnets, routes, and firewall rules. We'll view the subnet, so go to the default, and we'll find out is the VPC network and VPC networks. Let's click default. And I'll click subnets. Each subnet is associated with Google Cloud's region and a private RF1918 CIDR block for its internal IP address range and a gateway. And we'll have to view the routes. Routes tells virtual machine instance in the VPC network how to send the traffic from an instance to a destination, either inside the network or outside Google Cloud. Each VPC network comes with some default routes to the route traffic among its subnets and send the traffic from eligible instances to the internet. So in the left panel, we'll find out is route. In the effective route, we're going to click the network. And we'll try to select the default. And I'll click the region, and we're going to select the region by the what is the assigned US. I'm at US East 4 and click view. So I notice there's no routes for each subnets. So each subnets are managed for you, but I can create custom static route to direct some packets to specific destinations. For example, you can create a route that sends all outbound traffic to an instance configured as a NAT gateway, NAT gateway. So then we're gonna take a look at firewall rules. Each VPC network implements a distributed virtual firewall that I can configure. The firewall rules allows me to control which packets are allowed to travel to which destination. Every VPC network has two implied firewall rules that block all incoming connections and allow all outgoing connections. So in the left panel, click firewall. I will notice there are four ingress firewall rules. For ingress network rules, there are default allow ICMP, default allow inter RDP, and internal and SSH. These firewall rules allow the ICMP, RDP remote desktop, and SSH ingress traffic from anywhere, which is the 000/0 and all TCP, UDP, ICMP traffic within the network. So the targets, filters, protocols, ports, and actions column will explain the rules. We will go ahead and we'll click all default firewall rules, and we wanted to delete the firewall rules. Now, back in the console, we'll have to delete default network. Let's go back to navigation menu and we'll click VPC network. And we're going to find the VPC network. Let's select the default network and we want to click delete the VPC network. Let's click delete to confirm deletion of the default network. Type a default. We're gonna wait for network to be deleted before continuing. Now in the left pane, let's click routes. Now notice that there's no routes. Go to firewall. I notice there's no firewall rules anymore. Without a VPC network, there's no routes and no firewall rules. This time we're going to create a virtual machine instance. Let's verify cannot create the VM instance without a VPC network. Go to the navigation and we'll click compute engine. In the compute engine, we find a VM instance. We'll create instance. Close this. Now we'll accept everything default here. Let's click create. Here we say in the network interface, we'll notice no more networks and no network available error, right? Expected, I cannot create a virtual machine instance without a VPC network. What I'm gonna do next is to create a VPC network so that I can create virtual machine instance. So we're gonna create an automated VPC network with firewall rules. We're gonna replicate the default network by creating an automated network. So we'll have to go to navigation menu and find out what is the VPC network. VPC network, we'll find out the VPC network. And we're going to create a VPC network. The name of VPC network will say my network. Okay. And for the subnet creation mode, we want to use automatic. Auto mode network create a subnet in each region automatically. Okay. Go down here, firewall rules. We're gonna select all firewall rules. These are the same standard firewall rules that the default network had. So they will have have is the deny all ingress and allow all egress. Rules are also displayed, but I cannot check and uncheck them because they are implied. These two rules have two lower priority, higher integer indicated lower priority. Okay, so that's will allow here ICMP custom and RDP and also SSH rules are considered first. Let's click the create. When the new network is ready, we're gonna notice the network subnets that was created for each region. Then we're gonna to create the virtual machine instance in a region. So I can select the region and the zones determines the subnets and assign to the internal IP address for the subnet IP range. So let's now create the virtual machine in region. We're gonna create a virtual machine instance in region. I'm gonna select the region and zones determine the subnets and assign the internal IP address for the subnet's IP address range. So we'll go to compute engine and find virtual instance. Let's see if we're able to create an instance. Let's give a name for my virtual machine, mynet USVM. For the zone, I'm gonna actually pick is the A zone, and server is the E2, and machine type, we're gonna pick E2 micro. Click create. Let's now create another virtual instance. This time, mynet R2. Region 2 VM. Same thing, create. Look at the external IP for both instances that are temporary. If instance is stopped, then temporarily external IP assigned to the instance are released back to into the general computer engine pool and become available for use by another project. So we'll have to export connectivity for the virtual machine instance. We're going to export connectivity for the VM and specifically try to SSH to my VM instance using TCP/22, and by ping both internal and external address of my virtual machine instance using ICMP. Then we're going to export the effects of firewall rules on connectivity by moving the firewall rules individually. Let's verify connectivity for the VM instance. The firewall rules that are created with my network allow ingress SSH and ICMP traffic from either my network internal IP and outside the network external IP. Click the virtual instance. Click the SSH. If the authorize pop-up shows, click authorize. Again, SSH because it allows SSH firewall rule, which allows incoming traffic from anywhere for TCP/22. The SSH connection works seamlessly because computer engine generates the SSH key for me and stores data in one of the following locations. It's a default, and it can't create an OS login, and it stores the key in my user account. So we can actually ping, see 3 packets enter the internal IP of R2 VM. Ping is okay. I can ping my net R2 VM's internal IP because I allow custom firewall rule. I can also test to ping my net R2 VM's external IP. Ping is allowed. Let's now remove allow ICMP firewall rule and try to ping internal and external IP address of my net R2 VM. Go to navigation and find out VPC network. Find a firewall. Let's now remove the allow ICMP firewall rule. We'll have to go to VPC network and find a firewall. Let's select my network allow ICMP and I'll click delete. Alright, the rule is deleted. Let's now ping my net R2 VM internal IP. I can ping my net R2 VM's internal IP because I allow customer firewall rule. So let's test the R2 VM's external IP. And 100% packet loss indicates that I cannot ping R2 VM's external IP. It's expected because I deleted allow ICMP firewall rule. Now remove allow custom firewall rule. And it's allow all, so I have to delete. I have deleted, and we'll go back to the virtual machine. Go to my instance, and then we're gonna pin the internal IP. Here's 100% packet loss. Shows me cannot ping R2 VM internal IP. This is expected because I delete allow customer firewall rule. Now we want to remove allow SSH firewall rule. This similar we have to do is to go to firewall and we'll remove this firewall rule, allow SSH, delete. And I'll go to VM instance. Now click SSH. Is not able to establish SSH connection. SSH connection failed. After as I delete SSH allows SSH firewall rule. I exported how the full network along with its subnets, routes, and firewall rules. I deleted the full network and determined that it cannot create any VM instances without a VPC network. So I created a new automated VPC network with subnets, routes, firewall rules, and 2 VM instances. Then I tested connectivity for VM instances and explore how the effects of firewall rules on connectivity. To create the blog host. We're going to demonstrate the cloud storage and the cloud SQL. I create this virtual machine and I enable cloud shell. Here I'm going to create the cloud storage buckets and using the G cloud storage command. So I have to export the location and create a bucket. Click authorize. Now the bucket is created. We're going to retrieve a banner image from public accessible cloud storage location. The command is this to create a banner. And we're going to copy the banner image to my newly created cloud storage bucket. Here you go. I'm going to modify the access control list of the objects I just created so that it is readable by everyone. In the Google Cloud Studio Console, we're going to create an SQL instance. Close this. Now navigate, find the SQL. We are going to create instance. This instance, we're going to choose a database engine. We're going to select the MySQL. And for the cloud SQL addition, I'm going to place use the enterprise, and we're going to select the sandbox on the drop down. And for the instance ID, we'll say block db, and for root passwords, type password. Cisco 123. So we choose a password that I remember. There's no need to secure the password because I use MACD to connect and open access to everyone. Now we're going to find the single zone. The single zone in case of a start no failover. Okay. Let's now create incidents. So let's click the name of the instance to block DB here. I'm going to open a detail page right here. From the SQL instance detail page, we're going to copy the public IP. Let's still give it a minute because it's still being created. Now here you go, I can find the public IP. Copy this public IP. Let's click the username menu on the left side. We're going to click add a user account. Let's create user. We want to make is the blog DB user. We're going to allow host, any host. Let's click add. Click the connections. Find networking. We're going to add a network. Let's click the add a network. Network type is like a web front-end. Let's copy that IP and /20/33. So be sure we're going to use the external IP on my VM followed by /32. So do not use the VM's internal IP. Do not use the sample IP here. So let's click done. Now we want to go save it. Now changes made. I'll go back to my compute engine. Find a VM instance. This time not using the cloud console, I use SSH. Log into my blocker host. In the C, we're going to enter the Apache. Sudo narrow index PHP. Let's now copy all of this, paste all of this. Press Ctrl O, enter, Ctrl X to exit, restart the server. Shall we do a copy this external IP and open a new page, index.php. Now it's showing database connection fails. That's alright, because I have not yet configured PHP connection to my cloud's SQL instance. What I have to do is, go to change this index and cloud IP. We'll have to change with the public IP on my cloud. And password. Ctrl O, Ctrl X, enter, Ctrl X, and sudo service Apache 2 restart. Now return to my web browser. After reboot, I'm still not able to connect, so I have to go back to my SQL, click it, to the connection and networking. We have to add a different one. It actually should be web front-end, my Apache server IP, the public Apache server IP. Save this. Alright, so let's refresh the page again. See connected successfully. We're now going to configure application in a compute engine instance or use the cloud storage object. Now we want to find the cloud storage and cloud storage and a bucket. We're going to click the bucket that is named after my Google Cloud project. In the buckets, there's an object called my extended block PNG. We're going to copy this URL behind this link here, not what I just copy the public access. What I'm going to do is neither link or the public link, I'll try to copy here. Okay, now we're going to return to my VM. Still narrow the index page. Use the arrow key and find H1 elements. And enter. Type img src single quote, close it, and paste that link. We just copied, Ctrl O, enter, X. Now we'll restart the server again. We're going to return to my web page. Now show my external block image is here. So in this lab, I configured SQL instance and connected an application in the compute engine to do it. Also, I work in a cloud storage bucket. Run is managed the computer platform that enables me to run stateless containers that are invocable via HTTP request. Cloud Run is serverless. It abstracts away from all infrastructure management, so I can focus on what matters the most, building great apps. Cloud Run is built from Knative, letting me choose from run my own containers, either fully managed with Cloud Run or in my Google Kubernetes engine cluster with Cloud Run or on GKE. So the goal with this lab is to build simple containerized application imaged and deployed either through the Cloud Run. We're going to enable Cloud Run API and create a simple Node.js application that can be deployed as a serverless, stateless container, and will containerize my application and upload to artifact registry. We'll deploy a containerized application on Cloud Run and delete unneeded image to avoid incurring extra storage charges. Let's set up the requirements. Well, we're gonna click the Start Lab, then activate the Google Cloud Shell. Google Cloud Shell is a virtual machine that is located with deployment tool. So here, it offers the persistence to 5 GB home directory and runs on Google Cloud. So Google Cloud Shell provides command line access to my Google Cloud resources. Okay. It takes a few moments to provision and connect to the environment. When I'm connected, I'm already authenticated the project set to project ID. So the G-Cloud is command line tool for Google Cloud. It comes pre-installed on Cloud Shell and supports the lab completion. So you can list activate command name with this command: G-Cloud auth list. Click also write. I can list the project ID with this command like gcrowd config list project. First task is to enable Crowd Run API and configure my shell environment. We'll tap gcrowd services enable run.googleapis.com. I can also enable API using API service section of the console, and we'll set a compute region. Go. And we'll type location. Now in this task, we'll build a simple Express-based Node.js application which responds to HTTP request. Is to write a sample application. In the Crowd shell, we're going to create a new directory named the hello world, and then move my view into that directory. I'm going to make dir hello world and cd to hello world. Next, I will be creating and editing files. To edit files, I will use Nano or Crowd Shell code editor by clicking on Open Edit button in the Crowd Shell. So let's create a package JSON file, then nano it. Let's paste the code. Ctrl O, enter, Ctrl X. Most important, the file contains a startup script and the dependency on the ExpressWare web application framework. Next, in the same directory, we're going to create an index.js file and copy the lines. Nano index.js, paste it. There you go. This code will create a basic web server that listens on the ports defined by the port environment variable. My app is now finished and ready to be containerized and uploaded to Artifacts registry. You can also use many other languages to get started with Crowd Run. You can find Go, Python, Java, PHP, Ruby, Shell, scripts, and other from the code. Let's containerize my app and upload it to Artifacts registry. To containerize the sample app, we're going to create a file named the Docker file in same directory as source files. Added this nano Docker file. Now paste my code. Show you the Docker file. Copied, paste. Now we're going to build my container image using Crowd Build by running the command containing the Docker file. Let's paste this command. The Google Cloud project environment variable in command, which will contain my labs project ID. Okay. So cloud build is a service that executes my builds on Google Cloud. It executes a series of build steps, then where each build step is run in a Docker container to produce my code container and push it to the artifact registry, all in one command. So one push to registry, I will see a success message containing the image, this GCRIO project ID, then followed by the hello world. The image is stored in the artifact registry and it can be reused if desired. So let's gcloud and container images list. Here you go. And we're going to register gcloud as a credential helper for all Google support Docker registry. We'll configure Docker. That's to run and test the application locally from Cloud Shell. We started using standard Docker command. Paste this command. Then it should open a browser window showing the hello world message. It could also just simply curl the localhost, the 8080. See the hello world. Next, we will deploy the Cloud Run, deploying my containerized application to the Cloud Run is done using the command, adding my project ID like this. The allow authenticated flag in the commands makes my service publicly accessible. When I prompt it to confirm the server name, and we'll click enter. It actually reminds me the region problem. I have to set up my region correctly. And again, my region. Deploy it again. I can now visit my deploy container by opening the service URL in any browser window. Click it. Hello world is showing up. So I have just deployed an application packaged in container image to the Cloud Run. The Cloud Run automatically and horizontally scales my container image to handle and receive requests. Then scales down when demand decreases. In my own environment, I only pay for the CPU, memory, and the network consumed during the request handling. So in this lab, I use the gcloud command line, and Cloud Run is also available in the Cloud Console. There you go. Where Cloud Run does not charge when the service is not in use, you might still be charged for storing the build container image. I can either decide to delete Google Cloud project to avoid the incurring charges, which will stop billing for all resources used within that project, or simply delete the hello world image using the command like this. Why? Yes. And to delete the crowd around service, we'll use like this to clean up. Click white. So now clean up is done.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.